Thanks very much, Murli. It's a great pleasure to be here and an honor to address you this morning and to talk about a subject that is very important for me personally and I think for BP Solar. So, I can say actually that I'm not a technical expert on the storage of energy and the deployment of smart grids, so please help me with the questions afterwards. But I can say that in essence, these are not incremental technology improvements and that they do have the potential to be transformative for the energy industry. So I'd like to just set some context for the technology discussion. I pose it in the sort of sense of why should we, BP Solar, care? And the answer is that the essence of BP Solar is that we're focusing on our customers' needs. They're not really interested in solar panels. They're not interested in wind turbines. They're not interested in technology, or for that matter, anything that's aesthetic. What they really want is the highest value from investing in solar technology and getting the lowest cost of electricity in cents per kilowatt hour for their home or their business. So anything that adds to that or optimizes the kilowatt hours that they receive or reduces the cents in the cents per kilowatt hour is a really good thing. Of course, one of our key customers is, and a key stakeholder is the electric utility. And we also see that there is a need to address the electric utilities needs. For them, they have the challenge of providing a vital public service of energy provision to customers and an increasing demand on the requirements for energy. So a really challenging task. And these technologies play their part in doing that. So if we, this has turned out very interesting. So there's some numbers there by state that tell you how much the portfolio standards are for each of the states. In other words, how much renewable energy each state is required to generate. But the numbers are not important. And the context here is why should utilities care as well? So it's clear that an increasingly diverse energy mix, including gas, nuclear, coal, and hydro, as well as renewables, creates challenges in the supply and interruptibility of supply, and the importance, therefore, of a controllable demand. And for those that believe that renewables are not as important as I think they have been, I would say please think again. Renewables are expected to grow to about 20% of U.S. electricity generation by 2020. This is driven by a very dynamic and I believe progressive policy agenda from the U.S. government. So here's a chart that you can read. It's important to also note that this isn't just about large numbers and forecasts of energy economists. Nature has bestowed a tremendous treasure of renewable energy for this nation. And the ultimate or theoretical potential for renewable generation in the US beyond 2020 is enormous. And of course, we know that renewables could be even up to 50% of generation by 2050. And you can see the different categories of renewable energy that contribute to that in this chart. So clearly a very important resource. Of course, with this change and with the deployment of more and more renewable energy, and of course society demanding more electricity and more sustainable electricity, the traditional grid is evolving. New commercial structures are emerging, new technologies are being applied. For example, we now have commercially available small appliances, or smart appliances, I should say, in the home, that can measure the pattern of consumption and can switch or reduce their load as a result. So to give you an example, your refrigerator today can actually notice that you don't need ice at 4 a.m. in the morning, or if you're an insomniac, you do need ice at 4 a.m. in the morning, and can adjust and regulate itself to provide that service to you. So having a smart refrigerator is no longer a concept, it's a reality that exists today. Please don't ask me where you can buy one. I don't think we've got there just yet. But this type of smarter, energy management is a huge opportunity, and I think transformative for energy, and also for creating an opportunity for sustainable use of the Earth's scarce resources. So that's the good news part of the story, and so what are the sort of challenges here? And of course, there are many challenges brought about by renewable energy deployment. The variability of energy production, even if it's a steady pattern, it's a variable pattern, and it's a challenge. There is also uncertainty. Solar, in theory, out at night, wind out during the day, not to mention tornadoes, storms, clouds, all sorts of things that can really impact the availability of energy and the supply. This kind of variability is not something that utilities have had to necessarily cope with. Of course, there are always interruptions to supply from the current conventional sources of energy that exist today. But the sort of challenges that the renewables bring are a sort of step change in terms of management of supply. And of course, being a distributed form of energy, solar is actually very attractive in terms of being deployed at the point of consumption, but then it does require more complexity to connect and meter. And of course, the biggest gripe of all is the cost. So that it's only a matter of time and some technology, and we're going to get very close. And I believe it's a matter of only a few years where we can get to the point where these renewable energies, and solar in particular, will be grid competitive with other forms of energy on what has been a hugely declining cost curve and a price curve. I thought we'd just explore a little bit, how do you introduce flexibility in the supply chain? Oh, looks like there's a question. Please.
I'm sorry, I'm sorry to interrupt you, but I was curious, are you going to take questions? Is the pattern just to take questions at the end?
I'm happy to take questions anytime. I think we should have a dialogue. No, absolutely fine.
Only if you would say who you are and what your affiliation is first, and you can ask whatever you'd like.
Sure. Okay. If I might, because I find this area very interesting. My name is Dan Coffey. I write an opinion column with the Daily Transcript, and I write a lot about renewable energy and a variety of things. My background is chemical engineering and law. My question is, in your categories of variability, uncertainty, distributed generation, economics, where do you count for solar the fact that it only occurs during a fixed period of the day? How do you count that in those four factors?
Sure. Well, it's the variability. It's the variability in terms of its availability during the day and its variability during the day as the day passes. And there are many things we can do to smooth out the output of solar. Some of them actually at the level of a panel, where we can, for example, introduce electronics into the panel that mean that if a corner of the panel is covered up by a cloud, it doesn't stop the whole panel or even the whole string of panels from producing energy. In today's designs, historically in designs of solar panels, we've not had that flexibility. And advances in electronics have really helped us to think about the production in a different way. The reality is that solar is interruptible, theoretically and for sure in practice. And I think that poses probably some of the greater challenge. But the good news is it's available when the demand is needed. So it matches the pattern of consumption very well. So we'll see some charts later around sort of time of day and when demand occurs, and therefore when solar is available. And then the final point is that actually there's a lot of opportunity in really smoothing out the pattern of supply from solar and matching it with other forms of alternative energy. So wind tends to operate better at night, and the combination of the two can create some interesting opportunities. And we'll come to those in a second. I hope I've answered your question.
Yes, thank you.
Sorry, yes, I was talking a little bit about flexibility. So NREL has done some good work on what are the tools that we can use to address variability and uncertainty for renewable generation. This is a very good model, which tries to anticipate the demand side and the supply side needs as renewable energy penetration increases versus the cost of that energy. And I think the main message here is that there's much we can do before we run out of options with the higher cost options, and we can anticipate reductions down the cost curve as technology and innovation kicks in. So I won't go through this in detail, but you can see that there are opportunities for how we can manage that. This is the point I was making just now. So what you have here is essentially the time of day starting at sort of 0 up to 6 a.m. and then all the way up to midnight, and then the various demand needs. So that the blue line is, so the red line, sorry, is actually the pattern of demand. The blue line is the pattern of supply. And you can see that in the early hours of the day, clearly, there's excess energy produced for the demand that's needed, and so you can actually use the energy that's generated at that time to essentially store. And then, as the day goes on, there's a better pattern of matching of supply and demand, and then towards the end of the day, there's a big spike in demand, and we have a sort of deficit. So if you were to store, then you could store and then discharge when you needed the power and smooth out the pattern of supply and demand. And of course, you can start the pattern again at the end of the day with more storage. This is a sort of scenario that's been generated. And you can see that there's sort of 3 tiers here. There's a base load, there's the mid generation, and then there's the peaking. And the peaking is very, very expensive power. So if we were really to price solar at the price at the sort of alternative cost of energy for those peaks, I would say solar would be grid competitive today. So it would cost the same as or even cheaper. So because what you're having to do in that peak is run very expensive supply sources, so peak gas or peak oil, and you'll have to buy those at very expensive spot prices in order to satisfy that peak. And at that point in time, your solar cost, which is a little higher than obviously your other generation costs, would be very, very competitive. So very important, I think, as time goes on, that we start to see innovation in the time of day pricing of energy so that we can stimulate storage and stimulate deployment of renewables that are better matched to the pattern of demand. So there are many, many, as you can tell from this chart, storage techniques and technologies that exist today. And they have different operational economic characteristics, and they can be matched to different applications. So if you think about this, this is a sort of a split by discharge timing requirement, and then system power. And the reality is that sitting here today, we really only have one type of storage option for energy, which is pumped hydro, that can really do a significant volume of storage of energy. And you'll see at the bottom there, we're talking about a gigawatt, which is it's an enormous amount of electricity, but actually needed, unfortunately, in today's electrical system. So we're sort of limited. There's compressed air as well, which is another option. But unfortunately, these take hours to prime and execute. And so you don't have that ability to bring them on and off when you need like other sources of storage. And then at the other end of the spectrum, you've got flywheels or batteries that can be charged and discharged in sort of minutes or fewer hours. And there, unfortunately, you're constrained by their capacity and what they can deliver for